So this is, excuse me, this is Unit 6, not Unit 7. It's labeled that way in Schoology. For you guys online, I've posted the worksheet packet and the answer packet. That's for you guys here as well. I'm going to give you the worksheet packet if you're in person. But the answers to everything is posted. Our test is next block day, so that's Thursday for everybody, since all I have is even classes. Friday is one of those days where makeup day, like if there's a makeup test you need to do, we'll do it then. But if you're all caught up, which will be the vast majority of you, then that'll be a catch-up day, a study hall, whatever you want to call it. So for most of you, next Friday is great. A few of you may have to do some things, but that's not many of you. All right, sequences and series. Let's start. My old notes still say Unit 7, so Unit 6, Day 1. Which might mean you might find something somewhere still labeled Unit 7, but that's all right. All right, sequences and series. The first key thing is the difference between the two. And the trick is they both start with S, so it's easy to get them confused and backwards on which one's which. So let's talk about the difference between the two first. And the further confusing thing is the explanation of sequence and series also both start with an S. So it's a whole bunch of S's to get confused.
They also end in S.
A sequence is a set of numbers. A set of numbers. So it's like just a list of numbers. So like 1, 2, 5, 8. That's a set of numbers. It's a list of numbers. A series is a sum of numbers. So it might even be the same numbers, but instead of a list of them, we're adding them. So a sequence is a set, a series is a sum. Two things. The first thing is, I remember, like, I get confused every year too. I'm like, which one is it? In calculus, we use both too. They're alphabetical. Sequence comes before series. You got to get to the third letter before you can alphabetize. But Q comes before R, and set comes before sum. So that is how I remember which one's which. Sequence is the set, the series is the sum. The better news is, it's very rare that matters. Like, you usually can tell from the context of the problem if it's a sequence or a series. And I'm never going to ask you, is this a sequence or is this a series? So if you get them backwards, it's probably not even going to matter, because you'll be able to tell from the problem like what to do, and it won't really matter if you forget what the name is. So it's important to know both of them and how to work with both of them, but if you get the names backwards,
Is the set of numbers just a list of random numbers, or does it have any sort of like relations? Like it has the same repeating?
Okay, good question. The question was, the set of numbers, is it just like random, or is there like some pattern to it? And the answer is, could be either one. Now, we're not going to do much with random, because what can you do with them? They're just random numbers. We'll be dealing with ones that are patterns. And there's, we're kind of jumping ahead, but there's two different types of patterns. And so we'll get there. Before we get to pattern versus not pattern, let's talk about finite set versus infinite set. Do you know the difference between? Well, you know what infinite means.
Yeah. And finite's just like a certain amount.
Yeah, finite's like a certain amount. Like it stops at some point. So a finite set would be 2, 4, 6, 8. Stop. Finite set. An infinite set would be
Even numbers?
2, 4, 6, 8, ...
Yeah.
All of them. So finite versus infinite. We don't do much with infinite because like he kind of goes on forever, and it's like, well, how do I know when to stop? And what you don't. So you put a ... You can also have a finite sum and an infinite sum. So this could be 2 plus 4 plus 6 plus 8. Stop. And that would have an answer. That would have an easy answer, actually. That would be 20, but we'll leave it alone for now. What about 2 plus 4 plus 6 plus 8 plus ... That would equal infinity. Now, we'll get to this later. We may do this Thursday when the observer is here. It might blow her mind too. There is a way to add an infinite number of positive numbers and not get infinity.
Can you just
Can you infinity root something?
Infinity root something?
Root infinity.
I mean, you would have to do like that would be an infinite root.
Is there an infinite button on the calculator?
But there's not an infinite button on the calculator. That's a calculus thing, so we're not going to do that.
There it is, I think. Oh, no.
wait, calculus deals with infinity?
Definitely.
Alright, let's see. Hold on.
Yeah.
So if I go.
Alright. So infinite versus finite, that's not a big deal.
So if I go.
That's sort of the overview of what we're doing the whole unit. And you guys are really good. You started asking questions about what's coming up.
There is a thing. It's infinite cubed infinite.
Oh, this is bad form for you English people. Roman numeral 1 is types of sequences. And the bad form part is there is no Roman numeral 2. So that's not correct. Don't tell your English teacher I did that. But hey, this isn't English, so make up our own rules, right?
I wish you could tell that's my English teacher.
Well, you can't do that in English. You got to follow their rules. Just like in math, you got to follow the math rules. So types of sequences. I said a minute ago there were two types. There are two types of patterns. There's really two types that we'll deal with. There could be maybe not infinite, a whole lot of different types of patterns, but there's two that we primarily deal with. And the first type is arithmetic.
Arithmetic.
I know, it looks like arithmetic,
Is it not?
but arithmetic is what you do. Like we're doing arithmetic right now. Arithmetic is the adjective. Wow, we're having a whole English lesson today. Arithmetic is the adjective that describes a type of
Are
sequence.
they spelled the same?
Does arithmetic?
Can't spell.
I can't spell either. I think they are spelled the same. So the difference is the pronunciation.
But how would you know which one's which?
Yeah.
The context is right. That's exactly right. Now, you're right. Here, there's not much context other than
Arithmetic.
you heard me say it, and it's a type of sequence. So the adjective is arithmetic.
Is that a unit or is that a like a just for you to put A, B, C?
That A is for ABC. So I do have multiple ABCs. Now, some people like this unit because it is a lot of patterns, and if your brain is sort of geared toward patterns, which is a lot of what math is, and a lot of you are very good at math, so this will probably be good for you. A lot of people, even without knowing, like, we're going to talk about how to find the next few terms, but for one like this, I bet most of you are looking, thinking, I know what the next three terms are. Like,
Plus 3.
I'm only adding 3, like, what's the big deal? 16 and 19, you are correct. And a few of you, I even heard someone say, well, you just added 3 each time. Like, what is the big deal here?
Well, then what if it's different than this?
I'm sure it gets pretty difficult very
It's going to get a little more complicated, but not really today. Today it's not really going to get much more complicated. Arithmetic means you're going to add something each time. Add the same thing each time to get to the next term. So we're adding 3 each time. Another word that we'll use a whole lot on Thursday is that they have a common difference. That's a little bit weird because what does difference mean?
Dividing.
Not
Or-
dividing.
no, it's
Subtraction. So we're saying add and subtract.
You can add one way and
Well,
subtract the other.
we're adding 3 each time, but the difference between any adjacent set of terms is 3. So there's a common difference. We're jumping a little bit ahead, but this will make Tuesday a little easier. That common difference is we use the variable d for difference.
D for distance. Difference.
The distance between, you could think of it as the distance, because the distance between 4 and 7 is 3. Now, even though it's easy to come up with the next term, like just add 3, right? Like that's not a big deal. We'd like to be able to get to the nth term.
Oh no.
Nth, like, what if I want the 100th term? I don't really want to add 3 and like keep up with how many times I've added 3. Or my favorite thing on this test for the calculator part, when I ask for the 100th term, is I see this, 4 plus 3 plus 3, and then I see people just hit enter, which I guess is fine, but then you got to keep up with, how many times have I hit enter? And then something happens and then you lose count and you're like, oh, I forgot, I don't know where I'm at. So that's one way to get to the 100th term. But there's a much better way to get to the 100th term. In fact, if you wanted to get to the 100th term,
Can't you just...
we started with 4. Let's see if we can come up with this.
Wait a second. Can you... 4 times 4 is 6. Does that just happen to be like that?
We started with 4.
1, 2, 3, 4.
How many times, think really carefully before you holler out an answer, how many times would we have to add 3 to get to the 100th term? Like we got to add 3 some number of terms.
34.
99. You okay with that?
Huh?
Because 4 is 1,
4 is the first term.
and then 7 would be 2, so 2 to 100.
So there's this n minus 1 thing going on. It'd be 4 plus 3 times 99. I'd have to add 3 99 times. If that makes sense, the next 2-3 days is going to be a breeze for you, because that's kind of all we're going to be doing. So generically, it's the first term plus the common difference times n minus 1. Because if you want to land at the 100th step, you take 9, and you're already on step 1. It takes 99 steps
And
to get there.
If we don't have step 1, is it considered step 1? Like, let's say it starts at 16. That would be our step 1, right?
Right, if you didn't have the first ones and you were starting at 16, then your 100th term would be 16 plus 3 times 99. Tie.
The 99 part.
Yeah, the 99 thing. Let's label these. So that's the first term, the second term, the third term, and so on. If I'm standing on step 1 and I want to get to step 5, it's not 5 steps away because I'm already at step 1. It's 1, 2, 3, 4 steps away. That's the tricky part. I guess because you're not starting at 0, it's like you're already standing. If you think about climbing up the stairs, you're already standing on the first step. If you want to get to the 5th step, you don't take 5 steps because you're already on step 1. You take 4 steps. Better? Again, we'll revisit this on Thursday, so if it's a little fuzzy now, that's okay. Big picture is, one type of sequence is arithmetic. You add the same thing to get to the next term.
So is that formula only for arithmetic?
Yes. because you add something one less times than however many terms you're going for. Yeah. You can go too, Tyler. The second step, or the second type, is geometric. Well, let's do a little bit harder. See if you can figure out what comes next in this sequence. It's not a sum, it's a set, so it's a sequence. 1/3, 2/3, 4/3, 8/3.
16, 32, 64,
16/3, 32/3, 64/3, 128/3, 256/3.
512, 124, 248.
Yeah, et cetera, et cetera, et cetera. So how did you know? Like, most of you knew that was it, and your brain did all of this complicated math really quick. Like it's kind of cool how quickly your brain does things. That it takes some figuring out to make a formula for it, but your brain already knew how to do it. It's going to be the same thing here. Like, your brain knew what was happening. Your brain knew how to fill in the blanks. Now putting the formula on, it's a little bit harder. But what was your brain doing to get to the next term? You were multiplying by 2 each time. And so your brain recognized that, and then you just kept doing the pattern. So geometric means you multiply by the same thing every time rather than add by the same thing. So arithmetic is add, geometric is multiply. And in arithmetic, they had a common difference. We called it D. In geometric, it's called a common ratio. Like, what did I multiply by to get to the next term each time? This one was 2. And we'll use R for ratio. Again, let's think about the 100th term. We'll see some parallels here. If I want to get to the 100th term, well, we started with 1/3. I need to multiply by 2. Okay, 2 things to think about. How many times do I need to multiply by 2 to get to the 100th term? 99 again, because I already have the first term. So how do I multiply by something 99 times? Assuming I don't want to write times 2 99 more times. So the power, right? An exponent means how many times you multiply. So that 99 would go up there. So that would be a really big number. I have no idea that might even blow up the calculator.
Wait, why does it not just multiply?
2 to the 99th. Well, it didn't blow it up, but it's a big number.
Well, I mean, we had
Why
numbers
is it
64.
just 2 times?
Because
Because multiplying by 2 99 times means times 2 times 2 times 2 times 2 times 2 times 2. But a better way to write that is 2 to the 99th.
So if I wrote 2 parentheses 99, that would still be right?
Only if the 99 is an exponent. Right? 2 to the 99th is not the same thing as 2 times 99. That's not the same. So generically, the formula for a geometric is the first term. We always start with the first term, A1. Instead of adding, we're going to be multiplying. And we're not adding D, we're multiplying by R. And we're multiplying by R how many times?
3 to the 9.
Well, if I want, not necessarily 99, but I want to get to the nth term, n minus 1. So that's the geometric. Again, we're going to revisit these on Tuesday, but it's hard to only give you enough to do the worksheet. Like, it Just this is what comes next. The last type that we'll look at, it's not really a type, it's just if it's not a type, if it doesn't fit the pattern, some other pattern, some different pattern. This is where we'll really see if our brain is, if we recognize what's going on. So these are a little bit harder usually because it doesn't fit the same. One, 4, 9, 16. You recognize those numbers?
3, 5, 7.
They're square roots. They can be square roots.
Okay, so there's two things, there's two ways to think of it. They are perfect squares. Jason said, well, the difference is like, it's not a common difference,
You're adding
right? It's like a different difference, if that's a word.
Increasing by two.
either prime or odd.
So you're adding an increasing, yeah, so you could say, well, I'm going to add 9 to the next one and get 25, and then add 11 to the next one and get 36. But that's also 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and so on.
Wait, they're both the same.
Wait, say
Does
that,
that keep on going?
Uh-huh.
say that part again?
So that's a kind of a weird deal with the squareds. It's like, wait a minute, to get from one squared to the next squared, you add the
The next odd.
next odd number. And it always works that way, which is weird. It's like, whoa, what's happening? How does that work? It's a long, I mean, I could explain it, but it's a long explanation. Well, the short explanation is the second order difference. This is way more than we really want to care about.
Well,
The second order difference
I
is
remember we did that.
is common, and because it's a second order difference, it's in squared.
Uh-huh.
Wait, didn't you go to that?
That's way more than we're going to worry about. All right, so what the problems will look like today.
So does C have the formula?
So C doesn't have a, well, I mean, this one has a formula, a sub n equals n squared, but that just happens to work for that particular one. So the neither is, sometimes you can figure out a formula, sometimes not. Sometimes you just kind of figure out what's going on, and you don't get a formula, but you can figure out what the next term is. You know what? Let's do another one where,
Is C like just random numbers? Or
well, they're not random.
there are like going
There's
to
a
be
pattern,
some
but it's not arithmetic or geometric. It's some other pattern.
Okay.
And that's what makes it hard, because like, well, what's the pattern? Like, well, I can't tell you that ahead of time.
Mm-hmm.
You have to recognize the pattern. All right, what the worksheet today will look like is it arithmetic, geometric, or neither? Arithmetic, geometric, or neither. There's me abbreviating things. And find the next three terms. So we're not going to worry about using the formulas yet. We're just going to recognize patterns, do the next three terms, and be like, all right, that's enough for today. Let's just get comfortable with the three types, and we'll worry about the formulas more on Thursday. All right, so don't call anything out. 54, 18, 6. And we have 2 jobs, or we have 4 jobs, I guess. Oh, yep, those things.
Wait, 54, 18, is that?
Yeah.
54, 8, don't say anything. 54, 18, 6. Charlotte, Crystal, Haven. And then Ty will give us the... Ty. Hold on. You'll be
Wait a
okay.
second.
Charlotte, do you know what number comes next? Do you see the pattern?
54, not 5 and 1.
Oh, I do.
Don't say it out loud, unless your name's Charlotte. Charlotte, do you see the pattern of what's happening to get from one number to the next? You're dividing. What are you dividing by? Yep. Whoops. Divided by 3. So Charlotte, what's the next number? 2. Okay, Crystal, it is a little bit tricky now. We still want to divide by 3.
Why don't you just
2/3. Good. Haven, still dividing by 3.
I'm not sure of the fraction, but I know it's 0.2.
right?
It's not 0.2. You know what? Instead of saying dividing, well, let's say what we're multiplying by. 1/3. I think that'll make it easier. Well, that's why I'm going to do multiply, so I don't have to do keep it, change it, flip it. So 2/3 times 1/3, Haven, what's that? 2/9. So yes, we're dividing, but we really don't want to do division. We want to keep it as either adding or multiplying. So we're multiplying by 1/3. Ty, I almost walked you right up to your question. Is this an arithmetic, a geometric, or a neither? If we're multiplying by the same number each time, that makes it geometric. Arithmetic for add, geometric for multiply. Neither is just some other pattern that we recognize.
So we, like on the quiz test, so we would just have to find the ones that are in it, maybe the rate, and then what it is.
Yeah. Now eventually, not today, but eventually we'll say find the formula for that, and then find the 35th term. And then after that we'll say find the sum of the first 35 terms. But that's where we're going. That's not where we are today.
It's a lot of just. What'd you do?
Move that row to the side.
1/2, 3/4, 5/6, 7/8.
9.
You guys are just jumping ahead here. 9/10. How'd you get that?
Yeah. I don't know, like the fancy way to do it.
Right. This is one of those things where the brain is pretty amazing because most of you figured out what comes next. And I ask you to describe it, and you're like,
Yeah, I can tell you.
I don't know. I know what it is, but.
Yes, my paper.
So, is that a arithmetic, geometric, or neither?
Either geometric or neither. I don't think it's anything.
Okay, it's definitely not arithmetic. I like that because to get from 1/2 to 3/4, we would have added a fourth.
Plus 2/2.
3/4 plus a fourth is not 5/6, so not arithmetic.
So then,
Multiplying,
Plus 2x over 2x.
it's not multiplying either. It's a neither.
yeah.
Neither?
So the ratio
It's a pattern.
would be 3/4 over 1/2. That's the first ratio. The second ratio would be 5/6 over 3/4. And we could figure out what those are, but they're not the same. That would be keep it, change it, flip it. 3/4 times 2 over 1 is 3/2. 5/6 times 4/3 is not 3/2. Whatever that is, not 3/2. So not geometric.
So you just gotta do it in your brain.
So that's an either. Two more examples. A to the n equals -2 to the n plus 1. Yeah.
No, that's geometric.
That's geometric.
Yeah.
Because it's
So some people, and hopefully you'll all get there, can recognize what type it is first. But let's find the first 3 terms, because if we do the first 3 terms, then I think it'll be obvious which type it is. So the first term means a is 1. So -2 to the 1 plus 1
is 0.
Negative 2. The square of negative 2 is 4. Negative 2 to the third.
8. No.
8. Positive or negative 8?
Negative.
Negative, because it's a negative to an odd power, so negative 8.
And then
Positive 16. And you could keep going if you needed more, but it just said find the next 3 terms.
Doubling it.
Well, you're not
Doubling the previous one.
not exactly. You're not exactly
And
doubling it.
changing the signs.
And changing the sign. So what's the common ratio? What are you multiplying by?
Times negative 2.
So what does that mean for arithmetic, geometric, or neither? Geometric.
Yeah, geometric.
And again, some of you recognize right away that this was going to be geometric. You don't have to do that. Hopefully we get there. Last one. A sub n equals 5 minus 3n. We'll do it this way. We'll get 4 volunteers to help us out.
Forgot how to read, so I don't know if that's going to be enough.
Don't even recognize your own name.
Yeah, I
That's
can't
rough.
read, so.
So find the first 3 terms,
This test
and then you can figure out if it's arithmetic, geometric, or neither. Jamil, you got the first term for us? So A1 means plug 1 in for n to get the first term. So that's 2. Kyle, how about the second term? Good. Tyler, how about the third term?
It's negative 4.
It is negative 4. Caitlin, what's going on here? To get from one to the other? If you're not sure, keep going.
Wait,
So find the next one.
it's not. It's.
So you're right, you're subtracting. That's a yes. But that's not really an option. We have to say we're either adding or multiplying. We're adding negative 3. So it's arithmetic. Even though you're subtracting. Well, right, it's that whole adding is subtracting, but with negative numbers. So it's arithmetic. And we don't need to know this yet, but the difference is negative 3. So did a little more than we needed to today, but that'll get us ready for Tuesday.